Hello, my fifth graders, and welcome to lesson 6.4. 6.4, you might be saying. Miss Gorman, don't we usually start with 6.1? Yes, you would be correct. But for the fractions unit, we actually, I did not like how they arranged the lesson. So we are going to kind of skip around. 6.4 is dealing with factors. Now, yesterday, we just learned rules of divisibility. Today, we're going to be applying those when we try and find the prime factorization of many of our numbers. So, there's a couple vocabulary words that I used there that you might not recognize. The first one is prime number. So, all of our numbers, just like our letters, are separated into categories because we're human and we like to categorize things. So, those two things are composite and prime. So let's write those words down. Composite. Composite. Sorry. A composite number is a whole number. Whole number greater than 1. That can be written as the product of its prime numbers. You can write out numbers as well, but I know you like to shorthand it. So composite, basically two categories. Most numbers are composite. Most numbers you're going to multiply together to get. Most numbers can be broken apart into other smaller numbers in terms of multiplication. Then we have prime. Primes are special. Prime, they can only have two factors. One and itself. Wow, self. I'm going to put an E at the end, selfie. So prime can only have two factors, 1 and itself, and it has to be greater than 1. So 1 is technically, it's a weird one. So for example, 2. You cannot multiply two numbers together to get two whole numbers, to get 2. 2 is the only even prime number. It's very special. 2 is the only even prime number because any other number that ends in an even number is divisible by 2. So that makes it composite. So prime 2 is the only even prime number. After that, we have 3, 5, 7, 11, 13. Now, when we're dealing with the math that we're going to see in 5th grade, those are the ones we typically are going to see. We're going to see 2, 3, 5s, 7s, 11s, 13s, and you want to break down your number until you get one of those. Sometimes you'll see a 29 or a 23, but typically you're going to see these ones as we break down our numbers to become smaller and smaller. So composite and prime. Prime factorization is a very long and fancy word for taking those composite numbers and breaking them down into only its prime factors. And I do this using the tree method. So we make a factor tree. Now, what is a factor? That is something that I haven't mentioned in this lesson. I know I've mentioned it in previous lessons, but I'm still going to write down that vocabulary word because we tend to forget it. So in a multiplication problem, a factor are the two numbers being multiplied to get a product. So 3 times 2 is 6. These are the factors. They're numbers that are being multiplied together to get a product. Just like in an addition problem, we call them add-ins, and the answer. In a division problem, we call it the divisor, the dividend, and the quotient, right? Right, English guys, we like to name everything to an inch of its life. So these numbers are called the factors. This is the product. Today, what we're going to do is we're going to be taking composite numbers, breaking them down into only prime factors. Let's do some, y'all. Now, our first problem looks like this. I need a different color. I ran out of colors, so I paused you. Okay, so our first problem is going to be 18. So what I do is I put 18 at the top, and I do 2 arrows. Now, there's a couple rules of thumb here. As long as you are multiplying correctly, you're going to end up with the same answer no matter the route you take. So there are many different ways to multiply numbers to get 18. 2 times 9, 3 times 6, right? Either way you do it, you're going to end up with the same answer at the end. I like to divide by 2. I'm really good at my 2's. I don't know why, but I know my 2's really well. I see that 18 is even. This is where those rules of divisibility come in. 18 is even, so I'm going to divide by 2. So 2 goes on one side. 18 divided by 2 is 9. So in this row here, I have 2 times 9 is 18. Now, are any of those numbers prime? Yes, 2 is prime. So I'm going to bring 2 down. 9 is not prime. It's not one of my numbers I listed up here. So I'm going to break 9 apart. What two numbers multiply to get 9? Well, 1 times 9, yes, but that didn't get us anywhere. So I try to avoid dividing by 1. So what's another way that I can get 9? And that's 3 times 3. Now I have all of my prime numbers because 3 is prime, and this is as far as I can go. So if the teacher asked you, hey, what's the prime factorization of 18? You take it and you break it down until you can't break it down anymore. So 2 times 3 times 3 is the prime factors of 18. This comes in handy when we start finding common denominators and simplifying. All right, we're going to do a few more in our notes and then practice more within the class as well. So the next one I'm going to do is 32. Miss Gorman writes so big, y'all. All right, I have to go to a whole new page. We're going to go to 32. Now, you can just choose any multiple, and you're going to get the same prime factorization. I think that's the beauty of the prime factorization, is that will always get you to 32, but how you get to that prime factorization will depend on you. I see a number that's divisible by 2. I can divide by 2 in my head. I also know 2 numbers. So if 32 is too big for me to break apart, I do know 2 multiples that multiply to get 32, which is 8 times 4. So I'm going to do that. I'm going to use my multiples this time. 8 times 4 is 32. Now, neither of those are prime, so I have to break each of those numbers apart. So what multiplies together to get 4? 2 times 2. But yay, those are prime. How do I get 8? It is not 4 times 4. Now, here's the thing that does happen a lot with this, is we start getting into those multiples where it's 4 times 2 is 8, but we put 4 plus 4. So you have to be really careful about those. The only times it works is with 2. So 8 is 2 times 4. So 2 times 2 times 2 times 4. This is not prime factorization because I still have a 4, and 4 is not prime. So in our book, they actually drag each of the numbers back down, and then I split apart the 4. What times what is 4, which is 2? I know, 32 is a pretty long one. The prime factorization of 32 is 2 times 2 times 2 times 2 times 2. That's the prime factorization of 32. All right, we're going to do one more that isn't quite that long, and that's going to be 45. Now, when I look at 45, I immediately see that it ends in a 5, so it's not divisible by 2. 4 plus 5 is 9. I could divide it by 3, but the one that stands out most for me is 5. I'm going to divide by 5. So what times 5 is 45? 9. 5 is a prime number. 9 is not. 9 you get by 3 times 3. Now, technically, this is correct. 5 times 3 times 3. However, just like we start each sentence with a capital, math professors really like the smaller numbers to come first. So if I wrote this 5 times 3 times 3, I have a feeling that our online program might mark you wrong. You need to switch it, and you need to say smaller numbers first times 5. We're not even going to get into exponents, which is usually what we do as well here, but our book doesn't go that far. So 32 is 2 times 2 times 2 times 2. 45 is 3 times 3 times 5. These are all prime. This is the prime factorization of that number. If I was to multiply these all together, I would get 45. You'll notice this one, I have the smaller number in front and the bigger numbers at the end. That is factors and prime factorization. See you guys in a little bit.